All right, we're starting. Perfect. Thank you, everyone, and welcome to the reality of porting Kubernetes across microservice, across cloud providers. So at least I know the title. So my name is Federico. I work for Obscuro. Obscuro is a Canadian DevOps and cloud consulting firm. My experiences throughout infrastructure and cloud have operated over the past 10, 15 years in fintech as well. So I have two pieces of news. First one is good news. This will be an interactive session. So there are 6 slides with 6 questions from the audience. So it's sort of like a way for us to engage together, making sure that you can also, pitch in your ideas and follow through and put up with it. The other news is that I've been told last night by other speakers that, oh, you want to do an interactive session with a Swedish audience? Everybody will be super quiet. But I'm going to go through it anyway. So before I kick off the session, just to warm up everybody here, a couple of questions. First one, who has used Kubernetes in the past? Hands up. Perfect. So, right audience. So this will be a intermediate plus/advanced level talk. So you should find some food for thought. Here is less about depth, but very much about breadth. So we're going to cover lots of different topics here. So there's no intro to Kubernetes. We're just going to jump deep into it. We're going to get directly to 2024, and we're going to get to, OK, why does everybody adopt Kubernetes in enterprises and systems? People are using Kube because they want one thing and one thing only, which is portability. I've been told, and multiple websites and blogs and online articles talk about it as well, that Kubernetes is the best tool for the job when it comes down to cloud portability, when it comes down to multi-cloud deployments as well. This is why lots of enterprises that I speak with every day tell me, oh, we're adopting Kube over ECS on AWS. We're adopting Kube over some VMs somewhere else. Because we know that with Kube, we can package our microservices and move them across cloud providers. It is super easy. It's a thing. OK, perfect. So let's see if it is true. Now, who are we today in this room? We are a migration team. We have been tasked by our company to migrate an app from AWS to GCP, from EKS to GKE. We're going to do this exercise all together. And what are the rules? So some ground rules for us to play. First one is GCP landing zone has already been built for us. So our environment on GCP is there, ready to go. No questions, just like happy there. Networking is set up for us. IAM is set up for us. Everything is up. We just only have to worry about Kubernetes, which, by the way, is up and running. So we have a GKE cluster on GCP. We can also do this super easy migration. We can stop the world, so we don't have to worry about traffic shifting. We don't have to worry about moving some workloads first. No, we're just going to do like a one big bang migration type of thing. We don't worry about ingress management either. This will be an easy technical migration. One thing we have to worry about, though, are the stakeholders. It's not just about us. This is an application which has a set of stakeholders. We have backend developers who need to deploy their newest version of the code on the cluster. We have external users that need to be able to connect to the application. We have InfoSec people that want to be sure and certain that our Kubernetes cluster matches the security status of the company. We have also mobile developers that have this mobile application. So what does the application look like altogether? AWS, architecture. We have a whole bunch of users connecting with their mobile application on their phone to a backend. The backend is deployed as a set of 3 simple microservices, virtually stateless, on AWS. A user snaps a photo of an audience, for example, like here, and then uploads this photo to the first microservice that we see there. And this first microservice takes the HTTP request, perfect, parses the request, storing the object on S3, super easy, it's just an object on S3, and then some other microservice adds a watermark onto our image. There's some state management in Postgres. There's some user management in Postgres. There's one queue and one external message provider. We're sending message outside. We have Grafana and Prometheus to monitor the thing. So super easy. 3 microservices, 1 queue, 1 database, 1 object storage. It does not get any simpler than this. ChatGPT could write this up. So we're going to GCP afterwards. How does it look like on GCP? It is the same thing. It's the same thing, does the same thing, it looks the same. Same 3 microservices, same Kubernetes cluster. We're now just swapping a few things. We're not using maybe S3. We're using Google Cloud Storage. We're now using maybe our RDS for our Postgres database. We're using Google Cloud SQL. We're not using SNS on AWS. We're using PubSub. So we're just swapping a couple of services, but it looks the same, right? Oh, the other thing I forgot about on the previous slide is secrets management. We're using HashiCorp Vault on AWS because we want to be, open source first. But we're using a managed service on GCP called GCP Secrets Manager. Okay, how does it sound? Simple app, 3 microservices, 3 AWS services. Seems pretty straightforward, right? Perfect. So we have a journey. What is our journey? From AWS all the way down to GCP, and we want to respect the big promise, which is this is a turnkey migration. Some Kubernetes YAML that describes my microservices through GitHub Actions, change the endpoint via GitHub Actions, don't deploy kube control on EKS, deploy on GCP. So, first question. Given this YAML that we see here on the screen, will this work? Will our migration work if I just kube control apply this YAML on GCP? Yes or no? No. Why? Okay, the register. Perfect. So the register is different. We're using ECR to store our images on GCP. Perfect. On AWS. So can I pull an ECR image from GKE? What can I do? What are my options here? Come on, some ideas. Can I log in? Can I log in to an ECR registry on GCP? That's a good question. Can I log in? Yeah, of course you can. Of course, it's just like, but I need to provide permissions to my GKE cluster to fetch images from ECR, and I cannot use the IAM role I would use now because now I'm on GCP. So I hope you were able to follow me here, but like this is an infra thing, right? So we're using a different authentication model on GCP. So what are our options if you want to do it? Three options. Number 1, I start using open source and CNCF backtool Harbor being one. I host my own images. If I host the images inside the cluster, then when I can move things onto GCP, everything stays inside the cluster. I don't have to get out, and I can do it. Option 2, I keep the container registry on ECR, but then I have to be really clever in the way in which I manage my permissions, because now my nodes can pull images from ECR anymore with their IAM role or with their workload identity. I need to use some shim that I can put in between or some configuration. Or path of least resistance. I can just move to Google Container Registry. It's the same thing. It looks the same. Just going to move to Google Container Registry. Super easy. Pull the images from one side, push them to the other side. There's no magic here. Super easy to migrate those images across. Just one concern that comes to mind, though, is security. Now, we are working for an enterprise. This is a large company. So we can't just go there and just do the thing we want. We have to follow some processes. What processes do we follow in enterprises? Standardized frameworks, CIS benchmarks, NIST security benchmarks, all of these controls, right? So these controls, are they the same across cloud providers? No, they're not. GCP has a feature called binary authorization that doesn't exist on EKS. This feature says you can deploy here only if your image is signed with this signature key, right? And it's a fully managed service. So the thing here is, because we're following a set of standards that are standard for the company, migrating across also means changing our security posture because the two offerings are not exactly the same, okay? So we have to worry about this. We may have to enable that feature and then change our pipeline to sign the images. First, two realizations. Number one, if we have dependencies on services outside the cluster, it's harder to migrate. Second realization, security and external concerns are a whole game that needs to be played there. But our security team is a nice security team. They say, guys, nothing to worry about. Just go ahead with your journey. So we're going ahead with the journey. We're swapping ECR registry. Second question, kube control, apply this YAML, config map, and deployment definition. Will it work? Yes or no? No, it doesn't work. Good question. Why? Sorry, what's in AWS? The database is on AWS. OK, perfect. Can I connect to a database on AWS from GCP? Yeah. OK, fair enough. That's a very good point. So you can't turn it off. So you can't. Yeah, fair enough. Totally. But if I had database running, could I connect? It's public. So do I want to have it public? Do I want to have a VPN there? Do I want complexity? Of course not. So what I do, I move to GCP managed service. Now, because I'm using Postgres, and because this is 2024, whatevs. I can migrate. I just like PG dump, take all my data from one side, and upload it to the other side. Super easy in 2024. If this was 2022, would it be as easy? No. Why? Because Cloud SQL in 2022 was not matching RDS in terms of feature set. So once again, I have more capability on one cloud provider than the other. So I would not have been able, for example, to enable Postgres extensions in the same way. I would not have been able to maybe manage networking the same way. Cloud SQL on GCP runs in its own VPC, which then is shared with you, meaning no transit, meaning how do I get access to that shared VPC from on-premises. There are all these like networking concerns around it. But this is 2024, so what about the problems of 2022? These are old people doing old stuff there. So we're going to go ahead and not a major hurdle. If I want to increase my portability, though, what can I do? Well, as I said before, I could import inside the cluster RDS and just Postgres and just manage it myself with Postgres operator. Whatever is inside the cluster, very easy to move across. The trade-off with that, if I do that, is that then I have to manage it myself. Super easy to manage one, but what happens if I have to manage 20? So there are managed providers. The most famous one is Patroni, developed by Zalando. This is a shopping company. They operate hundreds of Kubernetes clusters in the wild, and they do this very complex management of them. Yeah, depends on who you are and how much money you want to spend into doing this maintenance, because it's a trade-off that happens here, right? The more I'm portable, the more I'm autonomous, the higher my service cost, the higher my velocity. Sorry, the lower my velocity. The more I use managed services, the more I'm on RDS, I get that velocity, but I'm more locked in, if you want, with the cloud provider, if I'm not clever about this. So this is the third, if you want, realization of all this. Throughout the talk, the game here is, given the CNCF tools out there, I can import stuff in the cloud provider, manage it myself, make it more portable, but is more costly for the company to run over the long term. OK, so this is third idea, portability versus maintainability. The more portable I am, the more cost I have to spend to port this across. OK, the journey. We're here. We're doing RDS. We've done change database registry. So what do we do now? We now deploy. The applications are magically up and running. Health status of the application? Yes, everything works. Perfect. So the user goes there and says, hey, Mr. User, upload an image for us. See how it works. The user tries to upload the image and gets a super sad 500 back. Error. Internal server error. Why? Ideas. Come on. Why did it crash? Miserably. Cloud storage. Perfect. So cloud storage, I just swap GCP S3 with cloud storage, right? They kind of like the same thing. It's like a folder in the cloud. There's an object storage in the cloud. Does the same thing. It looks the same thing, but it doesn't work. Why? Well, they're two different services, right? The API is different. The SDK you have to import is different. Okay. But I still have one image, one file that I've been uploading here for the past, and it's the same thing that we've been doing for the past 20 years, uploading one image into a folder. So it shouldn't be that different, should it? Anyway, options here. Option 1, keep object storage in S3 as it is right now. From GCP, I run to S3. Perfect. Can I do it? Yes. What is implication? Latency. Minimal latency. Don't believe the hype. Latency between cloud providers, almost in DC if you do the task. Super low latency. But the cost, right? So now I have to egress data from one cloud provider to the other. If we were to operate at millions and millions of objects, this would be a cost that we have to pay. So we want to avoid that. I can move object storage to GCS. Happy times. And I can do this in compatibility mode. This is a feature of Google Cloud Storage that all S3 competitors have. You can configure GCP to behave as if it was S3. So you can have a S3 API. You can use AWS S3 SDK and point it to Google Cloud Storage. The application doesn't need to change. The backend, the application changes. It's a feature that all S3 competitors have. Even R2 on Cloudflare is the same. Or I could import everything as usual, do my own object storage with Rook or Kubefast or SAFs. There's lots of alternatives around this. I could import the CNCF tools within the cluster, but I have to maintain them. Or I can use a feature called Container Storage Interface on Kubernetes. Who has heard of this feature before? CSIs. Hands up. A couple of people. Yeah, awesome. So CSI, standard feature Kubernetes, has been out for like a couple of years now. How does it work? Pretty straightforward. So we have Kubernetes, we have persistent volumes. These persistent volumes are just seen as folders. So I'm an application, I say, hey, can I get a volume? Of course you can. /opt for you maps to this volume over there. The container storage interface is a way that Kubernetes has to model this using drivers in a way that I could mount an S3 bucket as a volume, so as a folder, and then the application interacts with the S3 bucket as a folder, which is really clever because at this point, when I as an application make a claim for a persistent volume, behind the scenes, this could be swapped to GCS, Google Container Storage, Cloud Storage, which is super easy and is a very clever way of doing this portability game. Rather than connecting with an API to object storage, I work with the application on my local storage. Now, there are some limitations in the game. This is called Fuse, the way this way in which the file system is built up, is non-fully POSIX compliant, so there are some limitations in what you can do with these files. But if the goal is writing one file and writing it on the right bucket, whatever, this will work anyway. So this is a way, there's a possibility here, works and exists, has been out there for a while. It's a clever way of managing our drivers and our systems. Perfect. So, as we said before, moving to GCS means that if we decide to move to GCS and we just swap it behind the scenes without using the container storage interface, but just using the SDK, I have to change the identity of the system, right? I have to change the identity of the cloud provider. Now, as we said before, I have to change the SDK. If I change the SDK, how do I change the SDK there? And what happens if I have 50 microservices? What happens if I don't use my container storage interface at all? So I don't use this. I just swap S3 for cloud storage. I change the SDK. I can do it on one application, but if I have 2,000 microservices doing this type of SDK change that we see here with this tiny bit of code, this is like a bigger thing. So how can I do it? Well, I can decide to invest a very big migration process and start to migrate one after the other with some automation over a lengthy period of time. Or I can start to think about how we can shift concerns that belong into the code historically with the microservice architecture into the configuration. So I can create a anti-corruption layer outside of my application. Rather than having everything in the app, what I have a microservice outside that starts to mediate the access to the storage domain. And then when I have 2 or 3 applications, they just call this microservice internally that then calls S3 or GCS. So they don't see the change. Everything is just out there. Microservices pattern, because I can deploy as many as I want, I don't have to have everything in one place. And I can start to move across. So a few ideas I covered here. You have the CSI, the container storage, the storage interface for Kubernetes. Then you have this anti-corruption layer if you have multiple microservices. So you have different strategies there. And then we're continuing our journey. So we change the storage, we change the database. Kube control apply on this. Will it work, yes or no? So what am I doing here? I had my application that was pointing to SNS, queuing system AWS, SNS, SQS. They're the same, not the same, but very similar. Can I just change this with PubSub? Can I just like, whatever, I'm just going to tell the application to go to PubSub. Can I change it? Yes or no? No, why? Perfect. Same reason as before, right? So we would have to change the SDK, okay? I can't just like say, oh, I was using this AWS service before, just use this GCP service now. I can just change the configuration of the application. The application is like, yeah, but this is not, this is a different SDK, different API. What are you talking about? Yeah, okay, agreed. But why? Here is the question. The real question is why? Why the application says no, right? Because as we said before, we are having, we can go back, we are having to change the queuing service here. We have to change the entire thing, right? As you can see here, I have to change the SDK. AWS on one side, SNS on the other side. But look at the code. This thing is a standardized pattern that has been there in the industry for 25 years, even more, maybe 30 or 40. One microservice sends one message on a queue to a different microservice that consumes it. This pattern is super standard. There's nothing magical that SNS or SQS do as opposed to GCP PubSub. It's the same pattern, okay? So why does it look different? Why do I have to use it in a different way? And there are solutions to this, right? So one solution is Dapr. Dapr is a CNCF tool that tells you, okay, I have this super complex definition, but tells you, okay, given that the API service of this instance is different, but you're actually using it the same way, can we not define this as a fundamental principle, as a primitive of our architecture, so that I don't have to do anything? So Dapr is a 2019 CNCF tool that was started by Microsoft and has seen higher and higher adoption over the years. How does it work? How does it work? Super easy. Rather than calling a specific rather than calling a service outside of the cluster as a cloud store, as a PubSub or SNS, you call Dapr that then behind the scenes calls the application. Once again, mediator layer. This starts being more clever now though, because this becomes a API call to a sidecar container within your pod deployment. And then, rather than calling SNS, you're calling Dapr, that then, behind the scenes, as we said, calls PubSub, calls microservice. So now, yes, I can do what I was saying before. So now, to migrate my application, rather than doing anything clever, I just tell the application on the right, use Dapr, so use Dapr's SDK or Dapr systems, and then I change the configuration of Dapr. And I say, hey, Dapr, don't use AWS SDK, but use SNS, use PubSub. So rather than using AWS, use GCP. Now it works. Now I can change the configuration, one-liner, I'm on a different cloud provider. Why does it work though, right? It works because Dapper is really, really powerful behind the scenes and allows you to do this change. This is another takeaway of the section if you want. Shifting concerns from the source code onto the configuration. This is the trend that we see in industry as well. To make your applications more portable, don't change the application itself. Change the configuration around the application, and that then becomes cloud provider dependent. So this is very, very trivial to move, I think. And we can get to a view of what Dapper looks like. Okay, Dapper is a very wide set of features, has SDK for many programming languages, allows you to do service-to-service invocation, state management, independent of the underlying technology. Observability as well, secrets management, publish and subscribe, which is what we were talking about a moment ago. And you can, as I said, call Dapper that then calls the service behind the scenes, change Dapper's configuration, and you're all done. This is really good. Clearly, Dapper is not perfect yet because there are some limitations inherent in the technology. Number one, if you start doing clever things with the application, such as the application was subscribing to a Kafka topic here or an SNS topic here, and then during its life cycle changes the topic itself without coming from the configuration, Dapper won't let you do this, right? Because Dapper is more static in nature. But, you know, like, who does that for real? Like, not many applications do it, right? So the more interesting limitation with Dapper is about secrets management. Secrets management, as we said, we're going to HashiCorp Vault to Secret Manager before. We can do this as a library change, or with Dapper, we could just like call this HTTP endpoint with Dapper, super easy. So I can do, as I said before, application, Dapper, swap, HashiCorp Vault, plugin, GCP, Secret Manager does the same thing. There's one problem in doing this, which describes the nature of Dapper and some of the other CNCF tools that are similar to this. And you can see it in this secret format. So this is nothing special in itself. This is a secret with 2 keys and 2 values. This JSON object, right? The thing is, secrets with multiple key value pairs are only supported in HashiCorp Vault and not on Secret Manager. So what does our Dapper do then? Because this feature exists here, but doesn't exist on Secret Manager. Well, Dapper needs to adapt to the minimal common denominator, right? Which means that you cannot have all the advanced features. So Dapper only implements, in this case, single key value pair. So you cannot do this change with Dapper. This is to tell you, CNCF tools help you in the portability of the application, 100%. Dapper is a great application. And if you're making a cursory use of the application itself, of the pattern, if you're just using Secret Manager with 1 key value because you're calling an API endpoint, Dapper is amazing. If you're using a queue system and just passing messages from one service to the other, Dapper is amazing. If you're not doing this and you're doing something more advanced, Dapper is a problem. Okay, so let's continue our journey. Let's keep it going. Let's keep it engaging. Okay, so we're doing container registry. Change it? Yes. We're doing secrets management. Change it? Yes. We're doing everything. So the application is up and running. Our users are uploading data. Everybody is happy and it's coming to us. Yo guys, you're the best migration team ever. Well done. Then why is this guy screaming at us? Why is this guy screaming at us? Why does he have a t-shirt that says SRE and says, you're a bunch of crazy people. Why have you done that? Why have you done that? What's up with you? Forgot observability. Maybe, but we have that in one of the next slides. So not that for now. Not that for now. Why is he screaming at us? So this is a tricky question. I've done this talk in other audiences and nobody ever gets it because it's on me, because it's not clear. So one more hint. Let's see if you are the best audience. Come on, one more hint. Why do we have Terraform on a trash can? Why is an SRE guy screaming at us? And why is there a Terraform on a trash can? Why why did I put this? Like, am I like losing my mind here? Why is Terraform on the trash can? Where is it? Here. Well, because we've been using the console a lot. What did we forget about? Come on. Infrastructure as code. Thank you. So we forgot about infra as code. Why? Because we said, oh, but Terraform manages resources outside of the cluster. So, okay, if I was using my Terraform to define an S3 bucket, now I have to use Terraform to define a Google Cloud Storage bucket. I have to rewrite my entire Terraform code. There's just one problem. We are a migration team. We are Kubernetes people. What is this HCL Terraform code and nobody understands it? We're more modern than that. Is there not a better way of doing it? Of course there is. It's called Crossplane. Who here has heard of Crossplane, CNCF tool? A couple of people? Yes, perfect. So what is Crossplane? It is Terraform for Kubernetes clusters, inside the clusters. With Crossplane, you have the logic of Terraform. You can define YAML that describes resources external to the cluster. So I can describe, for example, a YAML for a bucket, okay, for an S3 bucket. And then kube control apply. My Crossplane controller then says, okay, this is a request. Here is my bucket over there. And it creates a bucket for you, and then you can use the bucket. So you don't need to use Terraform. You can manage resources external to the cluster with Crossplane. So far, so good. But I would still need to change my YAML now, because as you can see, my YAML over there says S3 endpoint. I need to change that. I don't want to change the YAML. I want to keep it the same. And Crossplane comes and really manages to help me out, offering an advanced feature called composite resources. So listen to this. This is a bit tricky in definition, but the idea here is pretty much the same. I can create custom resources on Crossplane that depend on the cloud provider. So that as a development team, we say, give me a Postgres database. And then Crossplane says, okay, based on my configuration, I can provide you with a Postgres database that happens to be RDS, that happens to be Cloud SQL, whatever your cloud provider is. This feature is called composite resources. It's a pretty advanced feature of Crossplane, but you can configure this in a clever way. So you can have an application similarly to persistent volume claims, having a claim, issuing a claim. The claim says, oh, I need a database, I need a queuing system, I need something really easy, and then I configure Crossplane to take this request and convert the request into applications code, into system code. So I have my portability done for me, right? Crossplane and composite resources enable all of this. Perfect. So let's continue with our journey. We're getting closer and closer to the end. We have our applications now. Are they up and running? Yes, they're up and running. So will it work now? Yes or no? Can users upload images? Come on. Say something. Yes, no, come on. Yes, why not? Like, we have it up and running. Now, the SRE team right now is not screaming at us. They are happy people. And whenever our application is down, it's very easy for us to get an email notification. Why? Well, because we've used some very easy managed services. Managed services that we use are Manage Prometheus and Manage Grafana on AWS. Perfect. Easy enough to move to Prometheus Manage and Grafana Manage on GCP. So this is great because the monitoring tools that we've used are very easy to move. Our dashboards are very easy to move as well with this, right? Because think about it, if I had not used Grafana, if I had used CloudWatch for this, then moving to GCP Monitor would have been a much more complex thing to do because at that point I would need to rebuild all the dashboards from scratch. It's like a long thing. So another takeaway. Cloud providers right now, each one of them has hundreds of different managed services. Among all these managed services, you can choose some which are really easy to use and very integrated. Some others which are slightly more hard to use or more complex to use, perhaps a bit less integrated, but more portable across. So when you're thinking about, I'm starting my journey, how to adopt this managed services, can I bring it into the cluster? Yes, I could bring it into the cluster and manage it myself, but it's really complex and time-consuming. I could still leverage a cloud provider offered service, but rather than using one that really ties me into the cloud provider, we're going to use one that is less of a concern if I'm thinking about portability here. So what I want to say is this is not a 0 to 100 where I either use open source and I have everything to manage myself, or I use the cloud provider, they manage everything for me and whatever. We're builders here. We can find the common ground, find a way in between that says using the cloud provider in a portable and easier managed way. Okay, so here is our final architecture with our systems. As we said, nothing surprising. We have now learned that Dapper really helps our migration, mediating access to systems. We've learned that the container storage interface on Kubernetes enables us to move very easily from S3 onto cloud storage as well. So what are the takeaways of this session right now in the next couple of minutes? So the first one is that everything, the big problem, quote, is that Kubernetes is not feature complete as today. Even if throughout its journey, Kubernetes has started to add more and more features within Kube in order to reduce dependency, this is still a complex ecosystem of a variety of services and systems out there. And because of this, if you think about this, all the offerings, the provider offerings on Kube, right, OpenStack and all the others, they are, sorry, OpenShift and all the others, they are offering additional services on top of Kube. We have not even covered CI/CD here, but OpenShift has a CI/CD embedded, has a container registry embedded, and so it's trying to reduce your dependency outside of Kube. Everything here, the complexities of the portability come from the fact that Kubernetes in 2024 is not feature complete, and you need a set of managed services or CNCF tools that can enable you to move and port your application across cloud providers. 2024, cloud portability is and remains hard work. Not easy. It's a complex, hard work. So what are the 5 final takeaways of this session? Number 1, as we said, ecosystem plays a major role. The big move is to move concerns from the source code into the configuration and enabling this configuration to take you across. We have open source that can help, but is a price to be paid in terms of velocity, because we have to manage this in terms of maintenance and managing cost. And so there's a clear monetary cost attached to it. The other thing we've learned, I think, is that moving one container across cloud providers, super easy. Moving 3 super simple containers that were running some super advanced modern code across cloud providers, much more complex. So here is the thing, here is the takeaway, is to think about the complexity of all this game. So folks, thank you very much.